Let's get into our eggsperiment. Now, take a spoon and drop an egg very carefully inside the glass. It's been about 24 hours. It's gotten really big, and the shell is completely gone. We've gotten all squishy and bouncy now. Hello everyone, I'm Doc Z from Dr. Sparks Junior Scientist Club. In our Darwin Club 14 Chemistry Basics, we're learning the difference between physical and chemical changes. I've got a really fun chemistry experiment for you to do at home today, but first, let's go over physical and chemical changes. Let's do it. Physical changes. 物理变化. A physical change is when something changes how it looks, but its molecules do not change. Size change. It could get bigger or smaller. Haha, like this piece of wood. Look, its size definitely changed, but the molecules inside are exactly the same. Size change is a physical change. Shape change. If I pump air into this balloon, it'll turn crazy big. Check it out. And then, when I let the air out, it'll go right back to its shape. The molecules inside stay exactly the same. Shape change is a physical change. Phase shift is a physical change. When water changes from solid to liquid to gas, its molecules are still the same, whether it is ice, water, or vapor. The molecules inside are still H2O. Phase shift is a physical change. Chemical changes. 化学变化. A chemical change makes something new. The atoms join together to make new molecules. When I put aluminum foil into this chemical, there is a reaction. Whoa, look at that. Its molecules break apart into atoms and then join together to make new molecules. Whoa, look at that. There's a color change. There's definitely an odor coming from this, and ooh, it's getting hot. Woo! I'm gonna put a balloon to catch all this air that's escaping. Ew! Whoa! When the aluminum went through its chemical change inside this liquid and created new molecules, the hydrogen atoms couldn't mix in with the new molecule, so the gas was released inside this balloon. Another thing about chemical reactions is that they cannot be undone, unless you use another chemical change. But do you think I can get the hydrogen from this balloon, put it back into the liquid, and get aluminum? I don't think so. So what am I gonna do with the hydrogen gas inside this balloon? Yeah! Blow it up! Ha ha! Let's get into our eggsperiment. Okay, so we're going to do an experiment that's very simple. You probably have everything you need in your kitchen at home. You're going to need an egg, a cup, a spoon, and some white vinegar. Eggs are interesting. Oops, I have changed this egg. But was it a physical change or a chemical change? Well, let's see. There was no temperature change, no color change, no odor. So the only thing that changed was its shape. The molecules inside are exactly the same. This was a physical change. Another example of a chemical change is something that you do at home all the time. When I put this egg into this hot frying pan, we're going to get, look at that, we got a color change happening. You can smell the egg cooking. That's one of the coolest things about food, is the smell of the chemical change that's happening while you're cooking. And now I have a cooked egg that's gone through a chemical reaction. But can I change this egg back into what it was before? No, it's too late. I can use this chemical change to make another chemical change when I put it in my body and use it as energy. Oh, it's hot. And that reminds us of another chemical change that happens in a chemical reaction. Temperature change. Whew, hot. And now it's time for your mission. Get a glass and fill it up with white vinegar, well, not too full. Now, take a spoon and drop an egg very carefully inside the glass. Don't crack it. Good. And now we can see the chemical change that's going to happen. It's already starting. Pretty much right away, you can see bubbles forming on the eggshell. That's because the vinegar is an acid. The eggshell is made of calcium carbonate. That's carbon and oxygen. Calcium is what's in your bones and teeth. It makes them strong. Carbon is in a lot of things. Vinegar starts to dissolve the shell. The bubbles are carbon dioxide, or CO2. We're gonna let these eggs soak for about 24 hours in this vinegar. This egg has been in vinegar for about 12 hours. I'm gonna take it out with this spoon. Now, remember when you're taking it out, be careful because these eggs are slippery. Here you go. Whoa, I can see that even after 12 hours, it doesn't really have a shell anymore and it's started to be soft. That's really cool. Okay, it's been about 24 hours. Let's take a look at this egg. Whoa, remember to take it out carefully. Oh, let's look at that. It's gotten really big and the shell is completely gone. Would you look at that? Wow, that's really interesting. So our vinegar had a chemical reaction with the shell, and really that shell is all gone. But it didn't have a chemical reaction with the membrane on the inside or the sac. So inside of the egg is still the same, but the outside, wow, it's completely different. That's amazing. It's gotten all squishy and bouncy now. That's even cooler. I can even drop it and bounce it. Look at that. That's some cool stuff. Give this a try at home and check out chemical reactions on your own. Now, do you want to bring this experiment up a notch? What could you do to make it different? How about this? What would happen if you use a different vinegar? Would that change things? Or how about your eggs? Would a brown egg or a white egg be different? How about a duck egg, a chicken egg, or an ostrich egg? But remember, junior scientists, don't just ask questions, find answers. I'm Doc Z from Dr. Sparks' Junior Scientist Club. Go forth, junior scientists, and do science!
Dr. Sparks, showing you science.